Hey, Upward Bounders. Mr. Harbinger here. I'm going to do a video on how the internet works and what happens when you do something in your computer. I'm doing this after my summer school class right now at CNS. So if something is really loud, the class next door, Algebra 1, I don't know why they're so rowdy today, but they must be excited about algebra. So sorry if there's like a noise every once in a while. And yeah, I shaved because we have a newborn and you can't kiss a cute little baby with a big scruffy beard. So I got to shave again today. Anyway, so my comparison for the internet, right? First off, the internet is different than the World Wide Web. The internet is an interconnected series of networks, like it networks devices. So the internet entails a computer, it entails a phone, it entails servers, it entails like a smart washing machine. Everything that's interconnected forms the internet. The World Wide Web is a web browser, kind of what you're looking at right now for CNS. You know, that's just like some web pages. There are other things that exist on the internet that aren't on the World Wide Web. Things like smart home devices and whatever. But that's not really the point of today. Anyway, so I'm trying to give you the basics, the architecture for the internet and how messages work. And next time we're going to talk about how to attack that architecture. So this is about cybersecurity. You have to know how things work before you learn how you can break things. And again, we're not trying to break anything. We are just trying to understand so we can defend and keep ourselves safe. So anyway, imagine you're at a computer, and you pretty much are right now, and you want to do something online. So I'm going to go to lemoyne.edu. I type it into the address bar, and I hit enter. So a bunch of stuff just happened there, and it happened really, really fast. So this talk is a longer version of what just happened. First off, you know I typed some characters in. All right, I typed in L-E, I also hit enter afterwards, but let's just say like LEMOYNE.EDU, enter. And the computer is supposed to know how to go get this information, the stuff on the screen. It's pretty smart, but it's smart because people told it how to do that. So, sorry, I got my baby monitor thing going on just in case my wife texts about, hey, baby needs help. I gotta be ready. So what happens? First off, our request gets digitized, right? It gets put into a digital format, and we have to be able to send that information somewhere else to ask for more information back. Like a web server wouldn't know about our request unless we actually do a request, right? Like we actually have to ask it for something. And so how does the ask happen? I'm going to do that with Microsoft Paint because I'm a really bad graphic artist and maybe this helps. So first off, I type in lemoyne.edu, that's called a URL, right? And I think that's the kind of thing that everybody your age just knows at this point, what a URL is. If you didn't know, it's just a web address. And I typed it in physically on my keyboard. After that, it's got to go out to the internet somehow, some way. But first, the LEMOYNE.EDU don't get sent like letter by letter. Instead, it sends something called packets. So in order to, I'm going to see if I can get some arrows going on here. In order to go out to the outside world, we have to packetize this. And that's my word. I don't think it's a real word, but transform it into packets. Now, packets, if you can imagine, are like little bundles of information. And I'm going to completely make one up that's absolutely ridiculous. But anyway, packets have a bunch of things. I'm going to really, really oversimplify. So I'm going to ask now what you think a good part of a packet is. If I'm trying to send information somewhere, now might be a good time to think about what kind of information would be in the packet. Okay, now that that's done, I'm learning to pause for Edpuzzle. I hope you know that there are parts like where it's going, right? We need to know exactly where to send the information because I can't just send it out into the world and hope somebody picks up the right information. The other way to think about this is if you're sending a letter to grandma or something like that and you really want to get some information to grandma, you don't just chuck the letter out in the world and hope that eventually blows its way into her mailbox or something like that. you should probably address it. So it needs a destination. The packet needs a destination. It needs to know where it's going. Typically, it wants to know where it's from. So maybe it's got like a home also, but it also needs the content of the message, but it's part of the message. It's not the whole thing, because otherwise packets would be enormous. Like if you sent a really, really big email, if you tried to email someone a video file, that would be the largest packet ever. And we don't want that. So instead we break it down into little pieces. And this is equivalent to like, if you want to mail grandma a letter, instead you send her one sentence at a time in a whole bunch of different envelopes. That's what's happening here. So it's got part of the content. Not only that, it's got other parts too, things like protocols, but we're not talking about that today. Other parts too. So TC Evan right now is yelling things like, don't forget about the protocols. And I know, but we're simplifying things. There are parts of the packet that talk about what rules everybody has kind of agreed to follow. We're not talking about that today. But anyway, we've got destination. We've got what's contained. So like the envelope is addressed and it's got part of the message, like, dear grandma, this week is going really well. And then you mail it out. And then the next one is like, dear grandma, and the address is on the envelope. What are you doing this summer? And then you send that one out. And so you send out all these different envelopes at the same time. But in the meantime, hey, you turned your information into packets, and there's a lot of them. And your software, like like a web browser, would break it down into little packets. So it takes your message and breaks it down into little pieces, and then it sends it out. And you're thinking like, how does it send it out? It turns your electronic data into binary, which you probably know, right? Because binary is a thing and people are kind of comfortable with binary. So which means it's just zeros and ones. So a typical packet might be something like 1101100111010. So whatever. And the computer knows how to interpret this. It takes blocks of 8 bits at a time. These are called bits, right? They're binary digits. And it knows how to break your message into bits. So it knows how to break them into zeros and ones. And then on the other end of things, it knows how to take all these bits and turn them into meaningful chunks. So it takes it by chunks of 8, which we're not doing right now. 8 bits is called a byte. And maybe you know what a byte is. Maybe you've heard of a megabyte or a gigabyte or a kilobyte. So those are just bigger collections of bytes. But whatever, it takes 8 and it transforms that 8 into a letter, like the L in Lemoyne. And if we use more, sometimes it takes bigger chunks, but whatever, right? So it's all in binary. And that message gets pulsed out through a medium. So if you're using like fiber optic cable, like Verizon Fios, maybe they're light pulses. And the 1 means the light is shining, and the 0 means the light is off. So my message, which is going out in terms of packets, which is like, hey, I'm sending this to the Lemoyne web server, and I want to know blah, 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 blah. Light on. It's still on. A millisecond later, it's off. A millisecond later, it's on, and it's still on, and it's still on, and then it shuts off. So I'm just reading the 110, 111. And on the other end of things, the light pulses are hitting, or maybe there are electrical impulses, like the electricity is flowing or it's not. Sometimes a laser beam is on or it's off. All of these represent if the transmission media, which is like a really fancy way of saying like the cable that we're using, is active or not. And it knows how to assemble those back together to get a real message. We're not going into the really like detailed specifics of how it does it. But imagine like this is just pretty much magic. I type in lemoyne.edu. It breaks it into little pieces of zeros and ones, and it sends it out through your modem, through your router. I'm going to use those things interchangeably. They're not really the same thing. If you are in Target, it's going to use Target's Wi-Fi router. If you are using your cell phone, it might send a message to like a cell phone tower. Whatever it is, it's the nearest thing that can help you send stuff out that you have access to. So that's kind of helpful to know. So it hits your router. after that, really, if you're thinking about it, the destination, seriously, is not what I'm looking for here. Come on. I forget how to do a shape. There we go. Ultimately, you want to get all the way down to the web server or a server, because that's got the information. It's going to fill requests. So I got to fix my mistake there. There we go. The question is, how do you get from your router to the server? And the problem is, like, if you send a letter to grandma, you send like 100 letters to grandma, your whole message is spread across 100 letters because the mail carrier can only handle one letter at a time, maybe. So you send all that out, they might get in weird order, right? They might get in unassembled order, and grandma's got all these randomly numbered messages, so we should probably number them, and the packet contains that too. Hey, I am message number 1 out of this whole thing, and I am message number 17, and that way it knows how to reorder them. That's really important also. So someone has to assign them a number, and someone has to reassemble it on the other end. Brain faster than mouth? It happens sometimes. Anyway, do you think that it goes linearly? Which means, do you think it goes directly from your router to the server? Okay, now that you've had a chance at that one, the answer is no. It doesn't happen linearly. It goes from your router to another router. So I need the down arrow. And I'm going to use that. So maybe it goes to Verizon's router or something like that. Or maybe it goes to some other router somewhere else. Or maybe it goes to another router. It's like, I don't know. This particular router, like, it hit mine, and then it sent the message out to like a central hub, maybe like a regional router. So then does it go from here to over here? No, it actually goes through a bunch of routers, right? Like, it goes through over and over and over a bunch of like middlemen, and their job is to kind of keep track. See, this time I'm going to bring the rectangle in a little bit more. Their job is to just keep pushing your message towards the spot where it's supposed to go. Everybody is constantly looking at your message going, that's not me, but I know the direction to send it. And they push it towards the destination, which is the server. And that's really cool. So I'm going to do an arrow. Eventually it ends up at the server. Do you think that it follows the same exact router path every time? No. No, it doesn't. Sometimes it takes a different path. So sometimes it might have gone a different way, and I'm not really going to care about closing the shape right now. And I don't have a nice diagonal arrow, so I'm just going to draw it like that. Sometimes it goes that way, and it goes to this router, and from that one, it goes down there. So sometimes it takes a different path. So one letter to grandma might go the bottom route, and the next envelope to grandma might go this route, and sometimes the next letter to grandma might go from your home router to this one over here. And so it takes a path that isn't always exactly the same for all the packets. The packets get split up and sent on their way. And it's like, hey, we'll go figure it out. And every single time someone finds one of your packets, they read where it's supposed to go, and they just send it further along in the right direction. So eventually, they all end up at the right spot, and the server's job is to kind of reassemble them, right? Actually, there's a router that sits in front of it, but whatever. So the server's job is to reassemble all the packets. And then it reconstructs the whole message. And it does it in reverse order of what's happening up here. You know, it takes the physical impulses, it takes the light pulses, it takes the electrical impulses, and it changes them into zeros and ones, and it changes the zeros and ones into like an actual message. And it's like, oh, they're looking for lemoyne.edu. And so it sends back code to your computer through the packets. It does the same exact thing, but in reverse the whole way back. And it sends back information on how to show lemoyne.edu. It shows how to reconstruct the page. It's like, oh, this page should be green. And it has this font on the top. And it has all this information. It's called a web request. And the server sends back information. If you've ever heard like a Minecraft server, same deal, right? You press a button on an Xbox controller, and that does something. Maybe it makes your character jump or whatever, but you press a button and that information hits up the Minecraft server when it's making a world or something like that, and it sends back information about what's happening, and it shows it on your Xbox, and it does it pretty quickly. Okay, so eventually it gets there and it goes back. So I guess my question to you is, what kind of measures do you think we take in case a router fails? So think about it for a second, please. What happens if this router fails? You know, how do we handle that? And so the answer is, and what happens if the server fails? I guess is the other question. So I had a fake pause there for a second. What happens if the server fails? So that was the real pause. We have backups, right? We have what's called redundancy. And the redundancy is basically like, I have another one that's ready to go just in case. There's another server and there's other routers that are just standing by and they're like, hey, I'm waiting. And if you ever need my help, just let me know. So this is actually really cool because we have backups. Just in case some things fail, we got to make sure we're ready to handle stuff. The problem is, though, we're wasting resources. Like, this server could be doing something, but it's not. It's just waiting for somebody to ask for its help. It's waiting for something to fail, right? So this is called redundancy. We have extra stuff just sitting around waiting. And we're redundant. We have a redundant system. If part of it goes down, the other parts of it can still handle it. It's not like everything just crashes. So the drawback is we're wasting our resources. This is like me having an identical twin. And it sits in the back of my math classroom and just sits there. And if I ever drop dead, he's going to get up and finish teaching the class. Hey, we have a backup. Awesome. The problem is we have a perfectly handsome, capable math teacher who's just sitting around not doing anything, just waiting for failure to happen. And so it could really be used somewhere else. So that's like the cost and the benefit of having backups is you're more safe in case something fails, but you're also not using all of your resources like you should. I think the other really good question is you typed in lemoyne.edu and it somehow transforms into zeros and ones. Somebody, somewhere, has to take that information and transform it. And you're like, okay, it's just part of the packets. That's like a hand wave. The really cool thing I think people should know is there's a server somewhere in the middle. It's called a DNS server. And I'm only bringing this up because we're going to talk about it a little bit in terms of security next time. So it goes right here in terms of how it's happening. And I'm going to label it. As long as you understand that the information goes to the DNS server, it's just too small to fit in there right now. Like that space, I didn't give myself enough space. So the DNS server's job is to take in text. So when I go to lemoyne.edu, so the DNS server is like, yeah, I know, you're trying to get lemoyne.edu. But servers and routers only speak in zeros and ones. So the DNS's job is to transform my message into zeros and ones. Like it's the translator. And old people like me are going to remember when we used to have a phone book. So if I ever wanted to call for pizza or something like that, I would open up the big phone book and I'd be like, man, I really want twin trees. And I would go to the business section and I would look in the T's and I'd look in the TW's and eventually I'm like, oh, twin trees in East Syracuse. Awesome. And I'd look at their phone number and I'd call them. So the phone book acts like a translator between the words, like my destination, and the number. And that's like a DNS server. A DNS's job is to translate the destination into like an address. Like, you know, maybe we're talking about like, I don't know, 425.321.658.0, like 114. This is a destination address, and we can transform these guys into ones and zeros also, and that helps, but you don't care about specifics right now. True or false, this means that the entire process is immune from hacking. You typed in lemoyne.edu. Naturally, the stuff you're going to get back is Lemoyne's homepage, right? Of course, that's false. Like every single true false question I'm asking is false. It's false because what happens if I've got someone in the middle spoofing it? And we're going to talk about this next time. It's called a man in the middle attack. But the problem is some people take in where you're trying to go and they redirect it to a different server that gives you something that looks just like it. But in the meantime, they're stealing your information. And so you think you're connecting to the real thing, but you're connected to just like a lookalike. And so that's a man-in-the-middle attack. It's just redirection, and we'll talk about it, but that is definitely possible. And this is a common hacking technique. This is identity theft. This is just mischief waiting to happen. Like you're hiding in the middle. No one might ever know. And that's an issue. So maybe you should be thinking about ways that you might fight that. All right. So my other question to get you thinking for next time is, how do you handle it when too many people are making server requests? What happens? So if a million people are trying to access this server at the same time, maybe even this one comes online and it's handling traffic too. But what do you think happens when a million people ask a server at the same exact time? And my comparison is going to be when I'm at home and my kids all want stuff and they want a lot of stuff. Maybe when they were like smaller, because right now they kind of handle themselves. Dad, can you make grilled cheese? Dad, can you do laundry? Dad, can you walk the dog? Dad, can we go to Target? Dad, can I have a Band-Aid? You get like a million requests in like 10 seconds. What happens? You know? So think about that one for next time, because that's another issue with cybersecurity. Next time, we're going to talk about how to attack this system. This is essentially how the internet works. I mean, it sounds really goofy, and there are other things in place too. I hope you're thinking like, wait, he didn't talk about what? So I didn't talk about some security measures. I didn't get into some of the specifics, but if you become a cybersecurity major, then you'll learn more of the specifics. It's really cool. And it's funny to think that everything you deal with on the internet does this. You know, like, it's funny because no one's ever like, oh man, I bet my stuff's hitting the DNS server right now. But it's possible. And what happens if the routers are really far away? Or what happens if it's got a lot of traffic at once? That happens too, right? If my router is handling a lot of different things, what happens then? And how do you safeguard the servers? How do you protect the servers from possibilities? So that's just something to think about for next week. Sorry I had to do it as an ed puzzle. I kind of wanted to make it somehow interactive with you guys, and I might post an activity really soon about stuff that you might enjoy. Also, in terms of like how to analyze a network or points of attack. But I'll see you guys in class next week. I hope everything was going great. And thanks for those of you that asked. My wife and my son are doing better, so I appreciate the well wishes, but we're doing great. He doesn't sleep a whole lot at night, but we're doing great. That's what babies do. So thanks again, and I'll see you guys soon.